Hello friend, I am Naval. You are watching Code with Naval. Welcome to Java series part 69. In the last video we saw daemon thread. In this video we are going to discuss about synchronization. So let's first understand what is the synchronization and where exactly use the synchronization. Synchronization have a capability to control the access of multiple thread to any shared resource. In a one process have a multiple thread and those thread can share memory. Okay, we already know thread can share memory. Java synchronization use where we need to allow only one thread to access at a shared resource. Here let's see, here we have a one requirement, one by one thread execute. Then there we use a synchronization because here only one thread can access shared resource. Here lock apply on object level or class level. If first thread executing, then that lock, that object lock that thread have, that thread not release that lock until and unless that thread execution complete. Okay, why we use a synchronization? To prevent object interference to another object. Here let's consider here one object, one thread is executing there, one thread is doing their work, executing that their task, but other thread interfering there and other thread getting their access and doing their work. Okay, that means their interference happen without a synchronization, but synchronization prevent that interference and synchronization execute one by one thread to prevent a consistency problem. Synchronization prevent a consistency. If we don't use a synchronization, then thread thread executing parallelly. First thread execute some time, then second thread, then third thread, then again first thread. There is no data consistency. That's why there is no data consistency. If first thread complete, if first thread executely complete, then only get second thread chance. Then second thread execute complete, then only get a third thread chance. In this situation, there is a data consistency happening and synchronization executing one by one thread. Here you can see example shared daily task update sheet. Okay, here you can see in this diagram, this one is a Google sheet and this one is an employee. There let's consider there one developer team, and inside a development team there 10 people, 10 developers. Okay, each developer need to update their daily task in this sheet. In every evening each developer need to update their task. Let's consider if first developer updating this sheet and second developer also updating same sheet. First developer updating in a seventh number row. Okay, seventh number row, and this third developer also updating the seventh number row because they don't know this first developer updating in a seventh number. If both developer updating at the same time, both developer content going at the same time in this Google sheet, then there will be chance data inconsistency because the first developer update some content in a seventh row, and this second developer also update some content in a seventh row. There then it will be chance data inconsistency. But this Google sheet already using a synchronization. Google sheet not allow the first person press save button. Okay, the first person press save button, then this first person data only go, this second person data will not go there. Okay, and second person immediately got this row is already someone using this row, you can use another row. Okay, let's see the practically. I'll show the practically. Okay, I'll simply open Eclipse and I'll simply create here one class. Okay, let's create here one class, and that class name part 69. Okay, here I'll simply create a one class. Okay, class sheet. Okay, this class name is a sheet, and let's see, we'll simply create here one method, public void and write method, write data, this method. Okay, write data. Okay, D should be capital, and here simply we write simply print for loop. Okay, int I equal to int I equal to, okay, let's give here int I equal to 1, then I less than equal to 5, then I plus plus. Then simply print this content. I'll simply use the system.out.println and I into k. Okay, and let's add here int k. Okay, here we simply create this class, and inside a class here we create one method, write data. Now I want to create a thread. This person, this you can see this 10% means here we have a 10 thread. Now we just consider 3%. Okay, 3 or just consider 2%. Okay, let's create a class for those person. I'll simply create a thread class demo. Let's use 69-1. Okay, this one is the first person, and extend thread class. Okay, and let's override here run method, public void run method. Okay, and here you can see here we need to create a shared object. Okay, for both this thread class we need to create a common object, and that's why here we need to get object from constructor. Okay, that's why I'll simply create here constructor. When we call this class, when we create this class object, that time only we need to pass object there. Okay, let's create here public demo 69, and here let's create this sheet object, okay, sheet and st. Okay, and here just create here sheet variable. Okay, sheet st, and let's create here this dot st dot equal to st. Okay, and here we need to call this method. Okay, which method? This write data method. Here we can simply write st dot write data. Here you can see st dot write. Okay, let's copy this st dot write data. Okay, let's pass here. I'll simply pass here 10 number. Okay, now I want to create a same thread one more, and let's change here, instead of 1 this one should be 2, and this constructor should be 2. Okay, now let's create an object for these two thread classes. Okay, I'll simply create here main method first. Okay, let's create here main method, and inside a main method I'll first create this class object. Which class? This sheet class object. Okay, let's create here sheet class object st equal to new sheet. Okay, new sheet. Now I'll simply create this two thread classes object, one equal to t1 equal to new demo 69-1, and here we simply pass this st object. Okay, then same thing I'll create one more object for second thread. This one should be second. Okay, let's add here also second, and here also second. Now I'll simply start this two thread. Okay, t1 dot start and then t2 dot start. Okay, t2 dot start. Here you can see simply we create one class, sheet class. Inside a sheet class here we have a write method, and here we need to call in a using a one object, only one object. Using one object we need to call this two thread, and by using this two thread we need to call this write method using a single object. No need to create a different object, because lock mechanism apply on a single object. Okay, let's see here. You can see here we simply create a first thread class. Inside a thread class here we simply, by using this object sheet st, this is the object. By using this object we call this method. and here also by using this object we call this method. And you can see here in a main method, here we create a single object and we pass this single object instance in this both constructor. That means here we are not creating a two object for calling this two time this write data method. We are simply passing a single object. Okay, let's save this and let's run this. Okay, here we pass, you can see here we pass 10, here pass, okay, here pass 5. Okay, let's pass here 5 and here we simply apply I into k. Okay, let's save and run this program, and here you got output. You can see here output first 5, 10, 15, 20, 25. Okay, this output we got properly, and then this one also got properly. This time we got a proper output, but execute one more time. Okay, here you can see, here you can see 5, 10, 20, 30, 40, 50, and this time not consistently output. Here we don't get consistently output. Here should we get 5, then 10, then 15, then 20, then 25. Okay, I need there is one requirement for me. I need execute a one by one. Okay, don't, these two thread should not be interfere each other. Okay, so how can we do that? Just apply a synchronize keyword. I'll simply use here synchronize keyword. You can see now here we didn't use any keyword. Now let's use here synchronize keyword. I'll simply add here synchronize keyword and let's save and run this program. Okay, and here see, first this second thread, this first thread get chance. Okay, here we pass 10 number. Okay, this first thread get chance, and this thread consume, this thread hold a lock, this object lock. Until and unless this thread execution not complete, this thread will not release lock, and this second thread not get lock, this thread not get key. That's why this second thread will not start until and unless this first thread execution will not finish. Okay, you can see every time we got a same output. You can see every time this first thread hold a lock and this first thread execute, and then only second thread get that lock, they get that shared resource access. Okay, here you can see every time this first thread hold lock and execute completely, then only second thread get access, and second thread hold lock, then second thread execute completely. Okay, then but there is an issue. What issue? Let's consider this 10%. Okay, this 10% using this shared sheet. Okay, and this 10%, this first person executing, this first person accessing this sheet, till that time this other person not get chance. If this other person even not open this sheet. Okay, even this other person not open this sheet, because this first person only access this first person only hold this sheet lock, because we apply here lock at a method level. Okay, you can see this one is our write data, this one is our sheet, and we apply lock at a method level. That's why this other person not get chance. Okay, this other person not write anything. But here in this Google Sheet, if you use a Google Sheet, then you can see there if this first person accessing, this first person writing something 7th number row, then other person only not get access that 7th number row. Other than this other person can write that, can read that Excel sheet, other person can access, other person can read other than this 7 column. So how can we do that? Because we don't need to lock this sheet until and unless this first person not complete their work. Okay, this other person should be visible. This other person can also be write something in other row. Okay, this first person only lock in a 7th number row. Okay, and this second person can write something in a 8th number row, but not in a 7th number row. So we need to apply a lock only for that particular row. So how can we do that? Let's see here Let's consider this one is a this operation is for 7th row. Okay, this operation is for 7th row and this operation is for 8th row, 8 and other than 7th row. Okay, this already this row is already using this first person. That's why this when this first person perform their operation, then this other person not get chance. Okay, other thread not get interfere their chance. Okay, so instead of adding a lock in a method level, we can simply create a block. Okay, synchronize block. So how can we do that? Here you can see synchronize block, and here mutex means we can simply pass this object instance. So how can we pass this? We can simply write here this, and here we pass this object instance. Okay, let's copy this and I'll simply add here. Okay, let's add here and I'll simply remove this. Here without applying a synchronization, in this for loop here we perform multiplication, but inside a synchronization here we perform addition. Okay, let's save this and again run this program. Okay, here you can see when this lock this one hold, then this one execute their all tasks. Okay, 6 7 8 9 10. Okay, this 5 times this execute their all task, then release lock, then this second one get chance. Okay, then this one execute 5 10 15 20 21, then again hold here this first one, this block, again hold this object lock, again execute 11 12 30 40 50. Okay, this 5 row. Okay, in this way we can simply use instead of applying a lock in a method level, we can simply apply a lock at the block level. Here we just need to write some code inside a synchronization, because only that code we need to make a thread set. We need to only that code consistently execution. Okay, that means instead of using a synchronize, instead of making this whole method synchronize, we can simply write that particular code inside a synchronize block. Okay, so here we saw simply using a synchronize method using a synchronize block. Here you can observe, here we write a separate, here we write a two thread class. Okay, instead of writing this two thread class, we can simply write anonymous class. So how can we do that? I'll simply comment this two thread class. Okay, let's comment this two thread class and let's save. Here you can see here we got error. Okay, let's comment this code as well. Okay, and I'll simply create a new sheet object, sheet st equal to new sheet, and here you can see here we simply create a new sheet object, and here we simply create a thread t1 equal to new thread. Okay, and here we simply write an anonymous class. Here inside this we can simply write a run method, public void run. Okay, run method, and inside a run method we can simply directly call. You can see here we call this, create here constructor and all these stuffs. Here we don't need to do all these things, here just add here. Okay, here anonymous class means no need to create a separate class. There is a no name for this class. Okay, anonymous class means no name class. Here we can simply create this class, anonymous class, for a t1 thread, and I'll simply copy this all code and again paste that code here and change this t1 to t2. Okay, t2, and here simply pass, instead of 5 I'll simply pass here 10. Here you can see here we simply create an anonymous two classes. Instead of writing this much big code, we simply using an anonymous class, here few line, we just need to write a few line and our code will be executable. Okay, now here we create a simply two anonymous class, then start this two thread, simply t1 dot start and then t2 dot start. Okay, let's save this and run this program, and here also we got same output. You can see here also we got same output. This first, okay, this block, initially this block hold lock. Okay, when this block hold lock, this block will not release until and unless this all code will not execute. Okay, you can see this block initially hold lock, then this block continuously execute 6 7 8 9 10. Then once this block execution done, then this again release, this block release, then this one get chance. Okay, this without synchronize, without thread shape, this for loop get chance, then this for loop execution start, then again here this block get chance, and this block again execute their 5, again iterate 5 time, 11 12 30 14 15. Okay, you can see whenever this block get chance, this block will not release until and unless all inside the data will not complete, all inside execution will not complete. Okay, here we simply solve object level lock mechanism. We can apply object level lock by using a method level lock. We can simply add here method level lock, or inside a method we can simply write a block, synchronize block, and there we simply pass this keyword, and we can apply a block, we can apply a simply particular line lock. Okay, by using a synchronize block. But in some cases, here you can see in some cases we can simply create a separate. Okay, here we saw object level lock. Why it's successfully? Because here we use a single object for this two thread, different two thread. But what if I create a separate object? Okay, instead of creating a single object, I'll simply create here separate object. Okay, you can see this one, and you can see this one. Now it will, okay, and remove this. I'll simply comment this and apply synchronize at a method level, synchronized, and let's run this. And here you can see, here you can see, here we don't get any data consistency. Here you can see 5 10 then 20, 5 10 then 15. We should be got 5 10 15 then 20 then 25, but here we didn't get any data consistency. Okay, here you can see every time we got a wrong, here we got a different output. There is no data consistency. Lock, when we perform a object level lock, when we perform a lock, that lock should be applied at the object level, and if we using object level lock, that apply only for a one object. Okay, but some cases we need to apply a lock at a class level, okay, at a static method level. So how can we do that? Now here we saw how can we apply a lock at a object level. Now let's see how can we apply an object at a class level. Okay, let's remove this synchronize and make this method static. Okay, this method is now static, and I'll simply, okay, let's comment, keep this commented code. Okay, now instead of creating here this class, okay, I'll simply comment this object also. Now here we are using a class level, here we are using a static method, and for accessing a static method we don't need a object, we can simply directly use a class name and we can access. Okay, let's see here, sheet dot write data, and here also we write a sheet dot write data. Okay, here you can see we simply, by using a static method, here we simply use a synchronized. Okay, here you can see by using a static method, here we simply use a, here we simply call this thread. Okay, let's run this program, and let's see what output we got. Here you can see 10 then 5 then 10 15. Here also we don't get a data consistently, here also don't get a data consistently. So here also we can apply a synchronize. So let's add here synchronize. Okay, let's see here synchronize, and let's save this and run this program. run as a Java application, and here you can see this time we got the consistency data. Here we got a consistency data. Okay, again run this, and you can see every time we got a consistently data. But remember here one difference. Initially we are using a object level lock. That means lock applicable at a object level, not a class level. But this static member interacting with a class level. Here lock apply at a class level. Earlier we are using a object. That's why their lock apply at a object level. Okay, and here lock apply at a class level. Let's consider this first thread get chance. Then this first thread hold lock at a class level. Okay, this first thread complete their execution and then release lock. Then second thread again hold lock at a class level. Okay, not at an object level, because here we are using a static member, and when we use a static member, that time lock apply at a class level, not at a object level. Okay, here also the same thing. Here also we can use a here you can see now here we are using a synchronize keyword with the method level. Here we can simply make this method, okay, make this method synchronize. That means here this method one by one execute. Okay, this method, if thread 1 is executing, thread 1 have this method lock, then thread 2 not have a access, thread 2 don't get access until and unless this thread 1 not execute their execution, not complete their execution. Okay, here also we have a same scenario, synchronize block. Okay, same like a object level lock. So how can we do that? Okay, I'll simply release this, and instead of this means this represent a object, this represent a current object, but here we are applying a lock at a class level. That's why here we need to write a class name. Okay, directly class name dot class. Okay, class name dot class, and remove this synchronize. Okay, let's see, remove this synchronize and save and run this program again, run as a Java application, and you can see this one hold lock. Okay, this block hold lock, and then this block iterate 5 times, 11 12 30 40 and then 15. Okay, then this block release lock, then this for loop execute. Okay, this for loop continuously execute, again this block hold lock, and again execute this block continuous. There the only difference between this object level lock and class level lock. Class level lock means you directly lock this class, no one enter inside this class, no one other thread enter inside this class. Okay, and this object level means you can only lock with this object. You can create other object, and that other object can access this class. Okay, that other object can access, but directly lock at a class level. No one access this class until and unless this synchronize functionality complete, this running thread and not execute their execution. Okay, here in this video we are simply understand how to work with the synchronize, how work internally synchronize. Okay, and what is the object level lock, what is the class level lock, and why we use a synchronize. We use a synchronize for making a thread safe, for a consistency, for a data consistency. If we don't use a synchronize, then two-person can perform an operation, two thread can perform operation at the same time, and that's why both data enter, both data write operation perform, and data inconsistently save. Okay, that's why here required a synchronize. Synchronize make a thread safe. Synchronize means thread safe. Okay, so in this video that's it. We will see next topic in the next video. Till that, bye bye.